I hope this is going to be clear enough to read on the screen. But this is my first video for Software Recipe Games 01, creating a game. This is an entire course for developing computer games developed to work via videos on YouTube. I'll be teaching these in my lessons first, but these are for you to refer to after the lesson has finished to make sure that you achieve the best you possibly can in your games development course. The idea of this video is first of all to develop your computer games by learning about the basic skills involved. It's designed to simplify the process of actually creating a game in the first place. Also, look at some of the theories behind why we're doing things in a certain way. Some of these videos you might not want to refer back to at any point. That's fine, you can still make the game without them, but a lot of the theoretical work is very useful for actually understanding why you're doing what you're doing. Throughout this course we'll be looking at 2D games rather than 3D games. That is, we're not looking at doing first-person shooters. We're looking more at the sorts of games that you used to find on older computers and mobile phones until recently. There will be a special lesson recorded onto the video of me actually going through the process of developing a pseudo 3D game like Wolfenstein or Doom. However, it's about an hour's worth of theory to go through first, and you will need to go through the theory to actually understand why we're doing what we're doing. It is very much more complicated than building a 2D game, hence why I don't normally cover it in my courses. Everything that you see can be built using C# on a Windows Form system. We're not dealing with XNA, we're not dealing with Silverlight, Flash or any other languages. Everything can be done in C#. Now of course there's more to building a game than just the programming aspect. All of this is important, but I will not be elaborating too much on it other than on this video. First of all, there's the concept behind a game. There are many different concepts, many reasons why games are made. The subject matter is obviously important, and sometimes so is the story. We're going to look very briefly at what needs to go into your design document in this video. We're also going to start looking at graphics and sound. The technical aspects will be dealt with by further videos. For example, actually drawing information onto the screen in the right order. How we actually deal with different objects, whether that be the player, an enemy or a tree that's in the environment. How we deal with collisions, like edges of maps that you can't go past. Synchronising the sound, so that when you fire a gunshot rings out, not 5 seconds afterwards. We're going to look briefly at how we load and save files. This will be used for saving games, loading level files up, and even loading graphics in the future. We're also going to talk briefly about the use of editor software. Modern game development does not just involve running through a programming language. There will be a whole series of tools that people use to build up parts of the program before merging them together, such as the levels, the graphics and the animations. So where do we begin with all of this? Well, we have to start with a concept. I've got some example concepts here for you. Rampage, where you play as one of 3 characters and try and destroy buildings. Mortal Kombat, a beat-em-up which got round the limitations of trying to have to draw figures by just digitising people. Lemmings, a very, very original puzzle game. Marble Madness, one of the first games to effectively use isometric 3D. Shufflepack Cafe, someone took a game of Pong, turned it into a pseudo 3D environment, stuck it in a space lounge that's similar to something you'd find in Star Wars, and turned it into one of the best-selling games on the Amiga when it first came out. Chase HQ, a racing game, but also involves having to find and crash cars off the road. Again, this may look like a 3D viewpoint, but is in fact a 2D game. R-Type, one of the most successful shoot-'em-up games. Pinball Dreams started all of the realistic physics pinball games that we get today. Flashback, a really engaging storyline combined with a platformer. Prince of Persia, on the first games to use motion capture technology on the main figure. Micro Machines, a top-down racing game for up to 4 people to play on the screen at any one time. Waxworks, another example of a pseudo 3D environment. It may look like you're inside a first-person view, walking around a building, but in fact it's all just static images. Alien Breed, a top-down shooter based on the Alien films. Again, in its time it was one of the most successful games ever made. Rocket Ranger, Cinemaware used to create fantastically gorgeous graphics, all cartoony, and create some really good B-movie style items. The point-and-click adventure, such as Monkey Island. This one is another isometric view game, which is Return to the Gulf. This one involves using a helicopter and gives the impression of being off the ground by having a shadow that's at a different height to the main character sprite. Shadow of the Beast 2, a very much tie-in with Shadow of the Beast, but again, fantastic intro animations rather than the fantastic game itself. Another World, a prequel if you like to Flashback, and again, very cinematic. Beneath a Steel Sky, another point-and-click adventure that came on 18 floppy disks. One of the original platformers on the Amiga, and the game that actually launched the Amiga into the main public consciousness, Batman the movie. Batman came out in 1989, this is the version of Michael Keaton, and they developed the Amiga Batman pack. So this was actually the very first game I ever played on an Amiga. Dune 2. The Dune universe has been spread over about now 20 to 30 books, and Dune 2 is one of the best examples of what we now call a Command and Conquer style game. Command and Conquer based a lot of what they do on this game, but this involved a lot more tactics in actually developing and building up your environment. So why have I looked at all these sort of old games, not looking at modern day games? We're not looking at COD or anything like that. Well, all of those games appeared on the Amiga. They all come from my era, the 1990s, and I had an Amiga as my first computer. It was also the first computer I started developing games for. Every single one of those games is well thought out in structure and is 2D, most importantly. It is feasible, using everything that you've learnt on this course, or will learn on this course, to build any one of those games, almost identical to the ones that you've just seen. There's also a real wide variety of examples of Amiga games available on the internet. There was such a good user community that there are over 3,000 different games that you can find on YouTube, and you can watch people playing them through, right the way through from the start to the finish. Some of these games take 8 to 10 hours just to play the first section. The Amiga was the very first gaming machine that people bought in their thousands because they could use it to do work on as well. This is the era of PCs when they were still confined to the offices. This is the era before Doom came out and changed the way that we look at games. So, what makes a good game? First of all, everything you're going to need to do is plan and put into a design document before you do any form of programming. You need to think of the structure of your levels if you have got levels. You might have an environment like GTA where you can just wander around, but even then you have to make strategic decisions about where you're actually placing items within that level file. There should be a difficulty arc, which gets harder as the game goes on. No one wants a game to be so impossible to play that within seconds you're dead, but you also want it to be more of a challenge the further you get through the game. The game length should be long enough to be a satisfying game. Modern day games range between 2 and 6 hours in length as a general rule of thumb. In the good old days, some games took 3 or 4 months to complete. Some games were never possible to complete. Elite and Frontier were 2 games that never actually had an ending as such. There should also, if possible, be shocks and twists in the game that you've got, just like in a good film. You should build up the suspense cliffhanger, bring it back down, and then start again. Quite often, Story-led games have been the most successful. Think of Halo as an example. They're used to capture the imagination, but they aren't always required. Doom's story was tagged onto the end of let's have a gun game that's first person. So we come to the design document. Everything that you are going to do and put into your game should appear in this design document. With initial concepts to put in. What's it going to look like on the screen? Is it going to be a top-down view game, sideways view? Are you going to aim for an isometric 3D view? Sometimes you might come up with an idea, start on this process of the design, and then change your mind halfway through. If you're using a design document, that's all well and good. If you started coding and spent 2 months of your life trying to produce something, that's not so good. One of the most major aspects of any game design document should be a run-through of how your game works. This is known as a walkthrough, and just like you see the solutions in some magazines about how you actually walk through a game, you should do the same for the game that you're creating, even though the game doesn't exist. This will give you an idea about puzzles to put in the game, how different levels might fit together, how different characterisations may occur, and even might give you a better understanding of how you want your story to develop. You need to do some game considerations. Is there going to be a goal to your game? If so, how does the player actually achieve that? The interface is how the things appear on the screen. For example, take Mortal Kombat. You've got 2 life bars on the screen, one on the left, one on the right. The left one refers to player 1, the right one refers to the enemy, even if you're reversed on the screen. It doesn't automatically switch the bars around. That's a conscious decision, because that way, as a game player, you can concentrate on your character's movement and just glance up at the energy bar when you need to. Having an energy bar on the screen at all isn't always the case in some games, but is a useful pictorial representation for people who are playing. What controls are you going to use for your character? Is it going to be directly mouse controlled, direct keyboard control? Are you going to point and click to an area to move your character around? Are you going to be seeing through the eyes of your character, so therefore the control matters even more? Data dictionaries are something I will talk about in the lessons, but for anything that you're going to store in memory or on the hard disk, you need to include that in a data dictionary. Class diagrams are again something I will go through in more detail with some of the more technical aspects of developing the game. You should also include flowcharts of how your program is actually constructed. The graphics and sound are of course important to any game, especially in modern day society. But, and there is a big but here, they should be left to the end when you've created everything else in your game.